Everybody, can you hear me? Can you see my screen? So today we start to learn chapter 5. The title of this chapter that's multivariable linear equations. You know, in the previous chapter we learned the single variable, right? We learned just like x plus 5, then minus x over 2 equals 4. So here we only have this variable x. You know, this one is still same with this. We don't have the other variables. So this is called a single variable linear equation. Now, start from this chapter, we will learn the linear equations but have more than one variable. Usually it's two variables. You can see this example. 2x minus 3y equals 7. So here we have two variables, x and y. So if you try to solve this equation, you know, you have two unknowns, but you only have one equation. You cannot find a unique solution for this equation only related two variables, right? So you need another equation. So that's the reason, you know, in this chapter, when we try to solve equations with two variables, usually we need to solve two equations. We call them system of equations. So now let's see an example here. This one is 5.1. So say consider the equation 2x minus 3y equals 7. In the table below, we record some pairs of the values of x and y that together satisfy the equation. For example, our first row tells us that x equals 5 and y equals 1. Together satisfy the equation we have. So if x equals 5, you plug x equals 5, you got 2 times 5. Y equals 1, so minus 3 times 1. So you got this one, 10 minus 3 equals 7. That's true. So that means 5 and 1. It's a solution of this equation. Then second row tells us if x equals 8 and y equals 3. So 2 times 8, that's 16, minus 9. So you got a 7. So that means 8 and 3 also satisfy this equation. That means x equals 8, y equals 3. Now here they ask you complete the table by feeding the meaning values. So everybody, let's first work on this. Can you send me the private chat? What's your value for y? Put here. Can make 11, x equals 11, and y equals that value you put here. It's a solution of this equation. So everybody, can you do this? Okay. Say you plug x equals 11. Now say that will be 2 times 11 minus 7 times y. This one give you 7. So then you try to solve this one, right? Try to solve this. Now let's see. Then we get this one's 22 minus 3y, then equals 7. So both sides minus 22, you get a negative 3y equals negative 15, right? So both sides divided by negative 3, you get a y equals 5, right? So then you can put a 5 here. Now let's check. 2 times 11, that's 22. So minus 3 times 5, 15. Yes, they give us 7. So that means this one's true. Okay? So now next one, they give you y equals 7. Then they ask you what is the value for x? Can be the solution of this equation. So now let's say max. Okay. 20, okay. Yeah, Max, you're right. Who else? Okay. Also, can you find some pattern here? Okay, if you can find some pattern, this you can find this answer very easy. Say when x add 3 from 5 to 8, then y will add 2, right? Say 8 to 11 add 3, then y from 3 to 5. So then here y plus 2. So x will plus 3. So that's 14. So you can check 2 times 14. Two times 14, that's 28, right? So then the 2 times 14, that's 28. Then 28 minus 3 times 7, that's 21. So you got this one equals 7. So that's right. Now, what is the value for this one? When x plus 3, y plus 2. So this one should be 9. Then you can check 2 times 17 minus 3 times 9. So you can get this one equals 34 minus 27. So that's equals 27. That's true. Then what is the value for this one? X equals 1.4, but what is the y value? Everybody do this. When x equals 1.4, then what is the value for y? Make this one pair of number, it's a equation, it's a solution of this equation. So this one, we don't have some pattern can find, so you just plug in 1.4 to replace x, then minus 3 times y, then this one equals 7. So here we got 2.8 minus 3y equals 7. So then negative 3y, both sides minus 2.8. So we get a 4.2, right? So then both sides divided by negative 3, get a negative 1.4, right? So that's negative 1.4. So you can verify if you plot y equals negative 1.4 here, then times negative 3, This one will give you 4.2 positive. This one will give you 2.8 positive. You add together, you get 7. So that means this one's right. So now you have this. Then they give you y equals 0.6. So then what is x value here? Make this pair, it's a solution of this equation. So then here you still can use a pattern here. From negative 1.4 plus 2 give you 0.6. So that means you need just plus 3 to this number. You get a 4.4 should be the answer for x. If you don't believe it, we can check. 2 times 4.4, then minus 3 times 0.6. Then let's check. 2 times 4.4, that's 8.8. Then minus 3 times 1.6, so 1.8. So this one equals 7, right? So that means this one's also correct. Okay, so from this example, we learned 2 things. One, a lot of solutions satisfy this equation, right? This one is not same as what we learned for the single variable linear equation. Remember that one, usually we can get this only have one solution. Sometimes it has no solution, right? Sometimes have infinity solutions. But this one, if you have 2 variables, whatever this equation is, if you try to solve this equation with 2 variables, only one equation, you always will get the infinite solutions. So here we list all these pair of numbers are the solutions of this equation, right? This is the first thing. Second thing, what we learn here, these solutions has a pattern. Say, for this case, every time when x increase 3, y always increase 2. Always. You can see here, from x from 5 plus 8, y from 1 plus 2 to 3. 8 to 11, that's plus 3. 3 to 5, that's plus 2. Okay? So why? Why this pattern there? It's just because this coefficient. If you can see here, every time when x plus 3, we can see here this equation, when x plus 3 minus y plus 2. Okay, and let me take this away. You can say this one always equivalent to, because if you simplify this, you expand it, you get 2x minus 3y. Because plus 6, then minus 6, it cancels out. This always equals 7. So that this equation tells us if x plus x and y is a solution of this equation, then x plus 3 and y plus 2 also will be the solution of this equation. If x, y, this pair is a solution of this equation, then x plus 3, y plus 2 also will be the solution of this equation. This is what we learned from this problem. Now let's go to next one. So from first problem, we already know if you try to solve an equation with 2 variables, you need 2 equations. One is not enough. If you solve it, you always got an infinite number of solutions. Now let's say here, they give you another equation. We have two equations. So how we can solve the solutions for this equation? To do this, now we have not learned the strategies or the skills to do this. The one way, let's just guess. Okay, let's play. If we are lucky, probably we can find the solution. So one way, now let's start from here. Let's first set x equals 0. If you set x equals 0, then plug to these two equations, then make these two equations only related to another variable y. Then you can solve these two equations. If you get the y value from these two equations, they're same. So that means you're very lucky. You get the solution, x value is 0, y the value that you found. It's a solution of these two equations, right? So that means you already get the solution for this system of equations. If you're not lucky, then you can keep trying, right? Until you find the solution. Okay, now let's try it. If we set x equals 0, then the first equation will become 3y equals 6, because x equals 0. So we got this. From this one, we can get y equals 2. Okay. Now, if we plug x equals 0 to the second equation, we can get the negative 5y equals 1. X equals 0, right? So from this one, we can get a y equals negative 1/5. So say this two value for y, they're not same. So that means we're not lucky. That means x equals 0 is not solution of this equation. Now let's try x equals 1. If x equals 1, now let's plug to here, we can get 3y equals 5. 6 minus 1. So then get a y equals 5/3. This from the first equation. If from second one, suppose x still equals 1, then get a negative 5y. X equals 1, so 2 times 1, that's 2. So both sides minus 2. Okay, so this one will be negative 1. So from this, we can get a y equals 1/5. So then these two numbers still not same. So that means we're still not lucky. Now let's try one more time. This time, let's suppose x equals 2. If x equals 2, then from the first equation, we can get the 3y equals 4, right? So then we can solve y. We get a 4/3. Then if x equals 2, plug to the second equation, we can get the negative 5y. This will be 4, both sides minus 4, this is minus 3. So we can get a y equals 3/5. They are still not same. So last try. Now this time let's try x equals 3. If x equals 3, we plug to here, we get a 3y equals 3. So that means y equals 1. Then when x equals 3, plug to the second one, we can get that's negative 5y equals, here that will be 6, right? 2 times 3, that's 6. Both sides minus 6, but here negative 5. So then from this equation, get a y equals 1. Wow, so we're so lucky. So then say when we set x equals 3, we solve the y value from these two equations, we get the same value, y equals 1. So that means x equals 3 y equals 1 satisfy these two equations. Okay, so that means we found the solution of this equation. X equals 3, y equals 1. This is the solution of this equation. Okay, but you can see this one, it's not easy, okay? To find a solution, you like a blind person walk on the road. You don't know where the direction you should go. So that means we need to learn some strategies, otherwise waste time. So now let's say we finished this section. Now let's go to next section. This section will teach you how to solve the equation. Okay, don't need to try. You can solve this one immediately. Okay, this strategy called substitution. Substitution, that means you get one variable from one equation, then you plug that variable to another equation. By this way, you cancel out that variable, make another equation only related to one variable. Then, by this way, we reduce the two variable equations to one variable equation. That's just to go back to the equation we saw in the previous chapter. Now, definitely we know how to solve the one variable equation, right? Now let's see this example, 5.3. Say, consider this system of equation. We have these two equations, have these two variables. So first, solve the first equation for x in terms of y. So that means we can solve x in terms of y. So that means x equals 4 minus 3y. Right? Both sides minus 3y. You get x equals 4 minus 3y. This is called solve x in terms of y. Now, B, plug your expression for x from the first part into the second equation. So that means you plug this one to the second equation. Because x equals this, you use 4 minus 3y to replace the x here. Then you make this equation only related to y, right? So now let's do this. That will be negative 2 times 4 minus 3y, then plus 5y equals negative 30. Okay, so then you can say this equation only related to one variable y. Now let's solve this equation. We can expand it each term first. That's negative 8 plus 6y plus 5y equals negative 30. So then now let's merge next terms. 6y plus 5y, that's 11y. Then here that's minus 8 plus 11y equals negative 30. Then both sides plus 8, you got 11y equals negative 22, right? So then both sides divided by 11, you got y equals negative 2. After you found that y equals negative 2, you just plug back here. You can get x will equals 4 minus 3 times 2. So this gives you 4 plus this minus 2, okay? That's 4 plus 6. So you got x equals 10. So then you need to go back check if the solution we found is correct. X equals 10, y equals -2, so that's -6. This equals 4. So that means first equation, that's correct. Now let's see second one. X equals negative equals 10, so this is -20. 5y, so -10. This one equals -30. So that means this one also correct. So by this way, we get the solution. That's x equals 10, y equals -2. It's a solution for this equation, right? See here, you don't need to try anymore, okay? You don't need to guess. You just solve x in terms of y from the first equation, then plug that to the second equation, make the second equation only related to one variable y. Then you can use all the strategies we already learned in the previous chapter to solve a single variable linear equation. Then you can get this y value equals -2. After you get this one, you plug back to the expression of x to get x equals 10. So this is exactly a very successful strategy called substitution to solve a system of equation. Now let's see next example. So this one is 5.4. Consider the system of equations 3x minus 2y equals 7. 5x minus y equals 9. They ask you which variable in which equation it's easiest to solve for in terms of other variables in that equation. In other words, which variable can you isolate most easily? Everybody tell me this. Which variable in which equation that's easiest to isolate? Because this one, it's decide if you can use this approach efficiently. Okay, definitely the y in the second equation. You know, from here, you can get a y equals 5x minus 9 from this equation, right? So both sides plus y. You get a 5x equals y plus 9. So then both sides minus 9. You get this. Now, plug this one, go here. So we can get a 3x minus 2 times 5x minus 9. This one equals 7. So simplify this, get a 3x minus 10x plus 18 equals 7. So 3x minus 10x, that's negative 7x plus 18 equals 7. So both sides then minus 18. So you got this one equals negative 11, right? So then both sides divided by 7. You get x equals 11 over 7. Then now let's plug back x to here. We can find a y. So that's 55 over 7 minus 9. So then we can write this one, it's 55 minus 63. So this one equals negative 8 over 7, right? So look, this number, it's not easy. Maybe we did it wrong, right? Now we need to have to check. Say if x equals 11 over 7, first equation will be 3 times 11 over 7 minus 2 times negative 8 over 7. So now let's simplify this one. Let's get 33 over 7 plus 16 over 7. So then 33 plus 16, that's 49. 49 divided by 7, this is 7. So that means first equation, that's true. Now let's check second one. That's 5 times 11 over 7 minus y, that's negative 8 over 7. So I got this one equals 55 over 7 plus 8 over 7. That's 63 over 7. So I got this one equals 9, right? So this one also correct. So that means the solution we get here, that's correct. That's x equals 11 over 7, y equals negative 8 over 7. Now I want to ask you a question. Why we choose the y in the second equation as a variable to prog to the first equation? Why we not choose x, but choose y? Does anybody know the reason? Have you seen, if we try to choose x from any equation, we need to do, say, if we choose x from first equation, we need to do x will equals 2y, both sides plus 2y plus 7, then divided by 3. So this gives us a fraction, right? When you prog this one to second equation, then you still have the fraction there. This operation of fraction definitely is much harder or time-consuming to operate of the integers, right? This is if you take x from first equation, you take x from second equation, that's same thing. The denominator, that will be 5. But if we take the y from the second equation, you can see all the coefficients are integers, right? If you take y from first equation, you also get the fractions. The denominator, that will be 2. So that's the reason why we choose y from the second equation to get a y here. Then we prog back to the second equation. So then when you observe, all the variable we are choosing has a coefficient, either it's 1 or negative 1. If you use substitution, the variable you are trying to isolate, that should be has a coefficient 1 or negative 1. By this way, you get that expression all related to integers, no fractions. So this way, that will make the operation will be much easier because all their coefficients will be the integers. That's the reason we choose y from the second equation. Okay, so now let's go to next example, 5.5. They ask you to solve the following two system of equations. A, 3r plus s over 2 equals 33 over 2. Then negative 5r over 2 minus 2r equals negative 37 over 2. You know, this equation, it looks very ugly. Why? Because they have a lot of fraction there. Fraction is hard to calculate. So first, we need to make this equation only related to the integers. So that means we need to cancel out the fractions. So to do that, both sides times 2. We can convert this equation to 6r plus s equals 33. Okay, both sides times 2. Okay, now let's see second one. We also do both sides times negative 2. If we times 2, you cancel out the fraction, but then you still keep each term as negative. That looks ugly. So then, that's the reason we need times negative 2 to each term. Let's see what do we get. Then we will get 5r plus 4s equals 37, right? So then say this is a new equation we get. Solve this equation equivalent, solve this one. So now, can you tell me which variable in which equation we need to choose to isolate? Okay, everybody know this? Okay, so here definitely to get s from this equation, that's equals 33 minus 6r. This one will be the easiest way to use the substitution. Then you get this s equals 33 minus 6r, then prop to the second equation. Then we can get 5r plus 4 times produces 33 minus 6r. This one equals 37. So now let's simplify this. Get a 5r plus 132 minus 24 equals 37. 24r, okay. So then now let's merge next terms. 5r minus 24r, so let's give us negative 19r. Then you plus 132. So you both side minus 132. 37 minus 132. So you got this one will equals 95. That's negative. Negative. So both sides divided by negative 19. We get r equals 5. Right? 5 times 19, that equals 95. Now let's plug back this one to here. We can find the s. So that equals 33 minus 30. This one gives us 3. Now that means we got r equals 5, s equals 3. Now let's plug back to say if this solution satisfies the original equation. So r equals 5, so that means this one is 15 plus s equals 3, so 3 over 2. So this one gives you 33 over 2. 30 plus 3, 33. So that means this first equation, that's right. Now let's see second one. Second one, you plug r equals 5 here. So that's give us negative 25 over 4. Then minus s equals 3. So minus 6. Then now let's simplify this. Give us negative 2. Then this was 12. Negative, okay? When you take a negative out, then both numbers left will be positive. So 25 plus 12, 37. So that means second equation is also satisfied. Then that means r equals 5 and s equals 3 are the solution of this system of equations, right? So then from this problem, you also learn the two things. One, if an equation has the fractions, first cancel out the fractions. Make the coefficients of each equation only related to the integers. Two, pick the variable has a coefficient 1 or negative 1 as a variable you try to cancel out. Okay, this is the two things you will learn from here. Now let's see how we can solve this equation. To solve this one, it's also it's decimals. Decimal is similar with fractions. It's hard to calculate. So now let's say first make the coefficient of each equation become the integer. Now let's see how we can make this one integers. So both sides times 10. So then we can say the first equation will be 12y equals 9.3 minus 3x. Okay, this is first equation. Second one, that will be, this one's 0.8. We just need times that's times 5, right? Times 5, then we can make this one's an integer. So this one will be 10x. If you decide times 5, 5 need times each term in this equation. 5 times 2x equals 10x. 5 times 0.2 equals 2.5. So 5 times 1.3, that equals 6.5. Then 5 times 0.8, that's 4y, right? Now, this one still looks ugly. The previous, all the equations, the x and the y, all on the left side. The constant term always keep on the right side. So that means we still need to simplify, make this both sides plus 3. 3x, you get 3x plus 12y equals 9.3. This is the first equation. Second one, we've got 10x minus 4y, then both sides plus 2.5. So this one will give us 9, right? So now we got these two equations. See here, what should we do? The all coefficient is not 1. So that means this one, we can simplify this. Both sides divided by 3. Let's see, this one will equals x plus 4y will equals 3.1, right? Now you can see this equation looks fine. This is the form we are familiar, right? So to solve this one, still use substitution. We can say the variable x in the second equation that's best to isolate. So from here we can get x equals 3.1 minus 4y. Then we can plug to this equation. Now let's see what we can get. That will be 10 times 3.1 minus 4y, then minus 4y, this one equals 9. Now let's simplify this. 10 times 3.1, we got a 31. Then minus 40y, then minus 4y, this one equals 9. So merge these two terms, we get negative 44y, then both sides minus 31. So 31 minus 9, that's 22, but that's negative 22, right? So then both sides divided by negative 44, so we get a y will equals 1/2. Y equals 1/2, then we can plug back to here to find x. So we got x equals 3.1 minus 2. So that means x equals 0.9. Okay, x equals 0.9, y equals 1/2. Now let's plug back to the original equation. So here, y equals 1/2, so that means this one equals 0.6. So is this one equals 0.93 minus 0.3 times 0.9, that's 0.27, right? So this one 0.93 minus 0.27. So looks like this one is not right. It's wrong, right? Cannot get 0.6 here. So that means where we did it wrong. We need to double check. So here, let's check. From this equation, first we times 10 both sides. We get a 12y equals 9.3 minus 3x. Yeah, that's right. Second one, we times 5 both sides. So we got a 10x minus 2.5. Then 1.3 times 5, that's 6.5. Then plus 5 times 0.8, that's 4y. Yes, that's right. Then we both sides minus plus 3x. 3x plus 12y equals 9.3. So then this second one, that's 10x minus 4y equals 9. That's correct. Then we simplify this one, both sides divided by 3. Got x plus 4y equals 3.1. So then we get x equals 3.1 minus 4y. Then plug back to this equation. We get 10 times 3.1 minus 4y, then minus 4y equals 9. So this one gives us 31 minus 40y minus 4y equals 9. So this one 44y, both sides minus 31, that's negative 22. Yeah, that's right. Then this one equals 1/2. This is correct. Then plug back to here. Oh, we got it here wrong. Got it? 3.1 minus 2. This is not 0.9. This equals 1.1. Okay? See, that's reason. This one definitely is not, you cannot escape. Sometimes everybody make mistakes. That's the reason why we need to check. Okay? So then now let's go back here. Y equals 0.5. That's 1/2. So 1.2 times 1/2 give you 0.6. Then here 0.93. Then here that will be 0.3 times 0.1. 1.1. That's give us 0.33. So this one minus this one gives us 0.6. So now let's means here the first equation that's satisfied. That's right. So we can get the first equation that's right. Now we need to check the second one. 2 times 1.1, that's 2.2. Then minus 0.5. This one minus this one give us 1.7, right? Now second one, that's 1.3 plus y, that's 0.8 times 1/2, that's 0.4. So this one also give us 1.7. Both sides are equal. So that means what we found, x equals 1.1, y equals 0.5 is the solution of this equation, right? So what do we learn from this problem? From this one, what we learn should be if the equation has the decimal as a coefficient, you need to cancel out that one, convert that one to the integers. Okay. Second one, if the variables on the both sides, you need to move all the variable to the one side. Then the constant term on the other side. Usually, we keep the variables on the left side, the constant term in the right side. Then you need to find which variable is easiest to isolate. So that's the variable with coefficient equals 1 or negative 1. Okay, so then now let's say we finish this section. Now let's go to next one. .3. Here we need to learn another very efficient way to solve a system of equations. Then now let's see this example. Let's see this one, 5.6. In this equation, we can say 2x plus 3y equals negative 11. 5x minus 3y equals 67. Now, to solve this equation, all of the variables, their coefficient is not 1 or negative 1. If you use substitution, this one takes time. But if you use elimination, this equation will be very easy to solve. Now let's see how we do this. Say A, add the equations. That means you add these two equations together. See what you get. So 2x plus 5x equals 7x. Then 3y plus negative 3y cancels out. So you get 67 minus 11, you get 56. So both sides divided by 7, you get x equals 8. After you get x equals 8, then you can plug to either of the equation, you can get a y. But always pick the coefficient is smaller. That will make the operation is easier. So then you can say plug to the first equation is easier. Then you can get 2 times 8, that's 16, plus 3y. This one equals negative 11. So then now we do both sides minus 16. You get 3y equals negative 27. So then both sides divided by 3. You get y equals negative 9. Okay? So from this equation, you get x equals 8. Y equals negative 9. Right? So then see, this one is very easy. You do this way. Add these two equations together, we cancel out the variable y. Make the equation only related to the variable x. Then this equation is very easy to solve. After we get the value for x, then we plug back to any equation here, we can solve y. But you can see plug to the first one, it's much easier compared plug to the second one. Because second one number is much bigger than the first one. The coefficient also bigger than the first one. You always try to pick the coefficient and the constant smaller. Then that number will much easier to operate. It's also not easy to make mistake. So this way we call the substitution. We call the elimination. Elimination, that means you cancel out the one variable. Make that variable has absolute value of same coefficient. Then, but the sign is different. Then you just can add together. Then you can cancel out that variable, right? Another way you can use the minus. If this two, suppose here that's both is plus 3y. Then you can use this equation minus that equation. Use one equation minus another equation. Then you still can cancel out this term, right? But if the term, the coefficients are all of them are not same, then you can think what number you need times to one of equation or to the both of equation, make the one variable have the same coefficient. Then you can use this elimination way to solve it. Now let's say another example here. 5.67. Consider this equation. Now, how to solve this one? Say this one, we don't have any variable coefficients 1 or negative 1. So that means use substitution is not good way. Then use elimination. We also cannot see which variable we can add together can cancel out immediately, right? But if we do a little bit work, say this one's 4, this one's 2. If both sides times 2, or times negative 2, then see what do we got here? Times negative 2, you get a negative 4x minus 6y, then equals 10. When you use a number times that equation, this number should times all the terms in this equation. So that's the reason we use negative 2 times all of the terms in this equation. Then you can say the term with x We can use substitution cancel out. Add these two equations together. You get a negative 13y equals 23, right? Equals 23. So then that means from this one, we get a y equals 23 over 13. Okay, so we can stop here. Thumbs up. The homework, that's all the problems behind each sections. We can stop here. Bye.